Okay, so next we're ready to jump a little bit more deeply into integrals. So first we're going to talk about antiderivatives. So this is section 4.2. So antiderivative. So this again is just a slight tweak on the idea of antiderivatives from Calc 1 and Calc 2, but the idea is basically the same. What's different is the assumptions that we're going to make. So we're going to assume that f is holomorphic. So if f is holomorphic on some set G, and if capital F satisfies that its derivative is little f, then we say that capital F is an antiderivative. So this is an antiderivative of little f on G. Okay, so really basically the same idea. An antiderivative is a function that you have to differentiate to get little f. And the only tweak here is that we assume that little f is not just differentiable, but that it's actually holomorphic. So this is what it means to be a complex antiderivative. Just as a few examples, if we were to take, say, the function capital F, which would be, say, I e to the iz, this is an antiderivative. So this is an antiderivative of the function little f is e to the iz. And that function's holomorphic on all of the complex plane. So that's an antiderivative there. We could take log z. So this is the principal branch of the logarithm. This is an antiderivative. So this is an antiderivative of 1 over z. And it's not going to be defined over the entire set anymore, over the entire complex plane, I mean, but it's going to be an antiderivative of 1 over z on the set of the complex numbers minus the negative real axis in 0. So it's going to be the complex numbers, but we're going to take away the quantities iy, where y is less than or equal to 0. Okay, so this is, if we wanted to graph it, this is going to be everything except this like little, we're going to take away just that part. And then the part that's left is going to be the region over which log z is an antiderivative of 1 over z. You could also check, just as a final example, that say sine of z is an antiderivative. So sine of z is an antiderivative of cosine of z. This is probably something that you've taken for granted, but it's slightly more complicated now because we're thinking of complex sine and complex cosine. But it's still true that it's an antiderivative of cosine on all of z. So you can check that if you were to differentiate sine of z. So if you were to differentiate that, you would get, this is e to the iz minus e to the minus iz all over 2i. And you can check when you differentiate that, you should get e to the iz plus e to the negative iz over 2. Okay, and I'll leave that to you to verify, but sine really is still an antiderivative of cosine.